for the introduction. Very warm welcome from my side to all participants of this webinar this afternoon. Today we are talking about energy efficiency in buildings. And here with the help actually of building automation and control systems. The shortcut of that is called BACS. You'll see this shortcut several times within this presentation. Remember, building automation and control system, that's actually the key that helps us to increase the energy efficiency of your buildings. Before, now I have to move the slide, just hold on. Yes, the challenges of today, we know them, climate change, developing energy strategy or energy strategies in different countries, the EPBD, actually the framework on the legislation level, then the goals, 2000 watt society, and at the end we all have one common goal. We have to reduce our ecological or CO2 carbon footprint of everybody. Now we want to show you today how you can increase this energy efficiency of your building and also actually decrease your carbon footprint. Before I start with the hard facts, I'd like to introduce the different bodies involved also in this presentation. Today I'm speaking on behalf of the eu.bac, of this European organization of the building automation and controls industry. It's an association based in Brussels and Frankfurt. We are representing about 95% of the European BACS, or the building automation and control system manufacturers. Our targets are mainly promotion of our technologies, then quality assurance within our industry, within our market, and their certification and testing is one key factor. Then positioning of energy performance contracting, proactive support of the standardization. I'm also member of the CEN TC 247 organization that drives the specific standards about building control. And then the different European directives. Here I have an overview of the companies who are member of this organization eu.bac. You see in the center also the logo of my company, of Sauter. Myself, my name, as already introduced, my name is Peter Schönenberger. I'm located in Switzerland, in Basel. I'm graduated engineer, electrical engineer of the Federal Institute of Technology in Zurich, and I've been working for the company Sauter since 1999. So I've quite broad experience in this business. I'm almost 19 years now, or 19 years now. Who is Sauter? Sauter is a company, building automation and controls manufacturer. We are based in Basel. We are a family-owned company, Swiss company, and we are located with subsidiaries all over Europe with our 100% daughter companies in almost all European countries, such as Germany, France, Austria, Italy, Spain, the UK, Netherlands, Belgium, etc., etc. So about 2,300 people, other employees, are working worldwide for Sauter, and we make a revenue of about 400 million euros. The company Sauter, we are on one hand side, we are a manufacturer of products. These are valves, actuators, sensors, control systems and software. But we also act in these European countries as a system integrator. We are delivering turnkey projects of building automations for mainly commercially used buildings. We are not very well established in the home sector. we concentrate ourselves, our forces on commercial buildings. Then we enhance all our products and services with after-sales services and even facility management in our market. Today, after this introduction, I'd like to talk about product certification and system certification. Actually, two methodologies developed within this eu.bac organization with the help of almost all member companies. Starting with the product certification. Product certification and actually labeling is actually the way to increase energy efficiency of the building. And there are various European directive and also national legislation regarding energy savings and energy performance of buildings. And for that we require a proof for energy efficiency. I can show you now in this presentation what's the impact of the accuracy of a controller used in the building to the energy efficiency of the building. This accuracy of the controller, we call it the control accuracy. This control accuracy has been defined in a European standard. It's this famous standard EN 15500. And we differentiate these three kinds of applications. We talk about hydronic water-based heating and cooling in buildings. We talk about air-based heating and cooling in buildings, and we also talk about electrical heating. We are differentiating our controllers based on these three classes. Within these three classes you can find subsections: room thermostat, electronic radiator valves, radiator heating system. That actually defines the application in your rooms, in your office, for example. The standard defines how to measure and how to calculate this control accuracy. What we do in our certification, we are testing the controller in a lab. The controller is tested in a control loop together with its sensor, its corresponding sensors, and with its actuator. The term actuator is usually used for a valve actuator. Most systems or many systems are water-based, so energy flow is controlled by opening and closing a valve, and for this valve we need a motor or a thermal, any kind of actuator that drives the valve. The sensor, what you see here, that's usually a temperature sensor. Very often in our business it's a nickel 1000 or PT, as a platinum 1000 resistor. The building itself, as well as the radiator or the fan coil unit, there we are working with a mathematical model that's based on MATLAB. This installation, leads us to also to reproduce the measurement conditions, and that means we have reprehensive measurement result. What we measured there or afterwards calculated is this CA value, control accuracy. That means how accurate the controller can hold a temperature set point of your room, and we measure that control accuracy in Kelvin, deviation in Kelvin. The bandwidth that's defined in this EN 15500 goes up to 2 Kelvin. To pass the test in this European and this eu.bac certification, we have set the limit of 1.5 Kelvin to that. but coming back to this a little bit later. What's the impact of the CA value on the energy efficiency? Of course, that depends. It always depends. It depends on your geographical location of the building. And you can see on this slide an example of France. France, that's a very nice country on one hand side. You know Paris, we all love traveling to Paris and visiting all the nice museums. But from the climate point of view, France is also a nice country because it leads from the North Sea, Atlantic to the Mediterranean Sea, and there are also Alps. That means almost all European climate zones are represented in France. You see in that chart these H1, H2, H3, the different climate zones. And depending on this climate zone, you can see the impact in the graph of the control accuracy to energy efficiency. That means let's go to a control accuracy we'll see later on. That's representative for the controllers we are testing of about 0.2. Then with 0.2, you get an increase of your energy efficiency of around 10%. Compared to a control accuracy of only 2 Kelvin. On the other hand, we can state that a change of your temperature in the room by 1 degree or 1 Kelvin leads in a change of your energy use of about 7%. The most efficient way always to increase or to reduce your energy cost is just lowering the set points. But we all know that does not correspond to the comfort demand of your employees or of the people working in an office. These tests I'm talking here are carried out by authorized test laboratories. There are 3 test laboratories authorized today. One is the BSRIA in the UK, the CSTB lab in France, or the VSP lab in Germany. There is a website available of the European, of the eu.bac, of the European Building Automation and Controls Association. You can see in the slide here the link, the URL to this website. When you, click on it, you can select your application on the left-hand side. You can select whether you have a fan coil unit installed, a chilled beam or a chilled ceiling. You can select the manufacturer and then also the products. And this example then, you can see what product a manufacturer has certified for a certain type of application, of terminal application in your room. The second type of certification I'd like to talk to you is the systems certification. We all know a perfect controller does not lead to energy efficiency if it's not used properly. Such a high quality controller also has to be set up, installed, configured in the correct application in the building. And that's exactly what we want to do with the system certification. The system certification is actually an audit. We are auditing a system, and with that we want to prove that the system works as designed and contributes to your energy efficiency. So, what we are trying to achieve with eu.bac system, we provide assurance that your BACS will be installed and managed at the most sustainable energy efficiency level while maintaining the comfort. And that's always important to state, while maintaining comfort. That's why we heat a building, because we want to achieve a certain level of comfort. How we achieve that, we state here, by means of the scientifically proven data based on European energy standards and I'm going to explain you the basic principle of these energy standards in this lecture today. Who is going to achieve that? This assurance is delivered by accredited experts trained by the building automation and controls industry. In other words, eu.bac is training people and is authorizing these people as accredited auditors to make such an assessment in a building. The outcome at the end is a kind of a label you can see in this slide here, and at the end you will get a mark or you'll get points. You get points first in the range of 0 to 100. 100 would stay for a perfectly maintained building, state-of-the-art with all functions implemented, and we also set a kind of a label towards these marks and express the energy efficiency with a A to G label. Later to that. This methodology is actually based on a standard as well. The standard, of course, is based on the European legislation, the EPBD. Based on that EPBD, the industry, together with CEN, have developed this EN 15232. That's a standard. It's called Energy Performance of Buildings, Impact of Building Automation Controls and Building Management. The calculation method, and in these standards we also find functionalities defined. Functionalities that have to be implemented to achieve a certain level of energy efficiency in the building. And based on this standard we have developed this certification scheme. The basics of the standards, I don't want to read the standard now, that's probably a little bit too boring for this lecture, but the basic principle of this standard is quite easy to understand. Imagine a heating system of a building. A heating system of a building consists of a generator. The generator could be a heat pump, could be a boiler. Usually we produce hot water somewhere in the cellar of the building. And then there is a distribution system, pipes and pumps and valves that actually distribute this hot water to the different floors and rooms. And now there is a way to control that. What we did in the past, we just produce hot water. And those who need it, they take it or leave it. Now that's not very energy efficient. That leads to a lot of distribution losses. The way described in this standard is that you have to see the demand for heating or hot water in the rooms. That means the consumers in the rooms, they have to tell you how much energy they really need to maintain a certain level of comfort in the room. Just imagine a room that's not occupied does not necessarily need to be heated. So if we install a building automation control system in our rooms, we can easily detect whether people are present or not. We can even detect how many people are present. And based on that information, we can demand the necessary energy to maintain the level of comfort. We create a demand signal, that's how we call it, and send that to the generator or in the building. And then the generator produces exactly that amount of energy that's needed to maintain the level of comfort. That's actually how this standard works, in simple words. Now, what we do with our methodology, eu.bac system, with this methodology, you can actually enter into a project in the very early beginning, even in the specification phase, when the planner, the specialized engineers, are starting to develop the concept of energy distribution in the buildings, they can rely on this methodology and define the necessary functions and functionalities needed for the building. And then during the construction, or respectively after construction, in the commissioning and handover, the control engineers can audit the installed functionalities with that theme and actually report the level of energy efficiency used. Later on, and that's this picture, it looks a little bit like a washing machine. We call that also the building washing machine. It's the life cycle of the building. During operation, of course, changes are going on. The building is renovated once, etc. This methodology can be applied a second, a third time to make sure that the level of functionalities is kept and the functionalities implemented work in a proper way. With this certification scheme, we also developed a set of KPIs, key performance indicators. These are key performance indicators that have to be implemented in the control system, and they help you to see in an early stage if, for example, a control functionality or part of a system starts deviating from its standard or normal values. And now all this methodology that works with buildings, with BACS, with building automation and control systems installed. And what is a BAC? What is a BAC doing? I've noted here the main functionalities of a BACS. Starting from the very right, automation. Of course, we control, we measure, we control, and we set. But a control system, and now moving to the very left, with visualization. A facility manager with such a control system gets an overview of the building. Visually, as a picture on the screen, he can see what's going on in what floor, in what room. And then he also gets notified if system parts are deviating. He gets informed if components fail. He gets informed if KPI is out of its range. And then it also helps him to operate, the operation part. He can adjust set points, he can set up schedulers, etc. And he can also use this control system as a reporting tool to report to for example, to the financial departments or to these authorities what's going on in the building and what's being done. When we go a little bit deeper into the rooms of a building, a room is controlled, an office for example, and this control contains actually 3 sections, and we show that in that triangle. On the bottom, you see in this blue bottom, we see the control functionalities used for temperature control of an office, of a room. Temperature control, heating, cooling. Yeah? And now we also know you can significantly reduce the cooling load of a room if you also have control over the solar protection, also shadow blinds. If you can integrate automatic shadow blinds into your control system, you can automatically reduce the cooling load of the system. That means also save energy like that. The next, of course, is when you include or integrate the control of the shadow blinds, you also have to integrate the control of the illumination of the light. Light is also has a high impact on energy efficiency of the building, of the heating and cooling load of the building, and of course a direct impact on the comfort level in the room. So in our room control, and that's also set up with this eu.bac system audit, we have a look on all these three groups of functionalities in a room control. Now here on this slide I'm going to visualize you a little bit more in detail how this is technically set up. We go to on the right hand side, we see actually equipment installed in a room. And you remember from my chart before, in the room we have to detect whether there is a demand for energy in the room, whether the room is used or not. So in such a room control we are using presence detector and illumination sensors to control the light. With such a presence detector I also know if people are present. In some cases I can even count the number of people in the room. There are CO2 sensors installed in a room. With these CO2 sensors I'm measuring the quality of the air, but that's also an indirect indication of the number of people who are present in the room. In such a room we are working today with IoT devices, with communication protocols for the illumination, like DALI here, with specialized protocols for the control of the window blinds, SMI, and with some analog and input signals to measure temperature or to control radiator valves. The central part here is a controller, and this controller that's collecting all that information and sends this information through a standardized communication protocol through the communication backbone in the building. The communication backbone here, the vertical red line you can see, we are using in the industry today BACnet IP as a communication protocol. So here all information of the different rooms and floor level is collected and the demand signal is calculated like this and like this. The generator part in the building, the air handling unit, the chillers, the boilers, the heat pumps, etc. can produce exactly such amount of energy that's really used in the building. That's again the schema I showed before, how the standard works, and against this we are certifying, auditing a building. This chart again shows the same as the chart before a little. You see this in detail. It's just you have to turn it by 90 degrees. We see here on the bottom energy generation part, cooling, chillers, district cooling, the heating part, boilers, district heating, heat pumps. Then we come to the distribution, and now you can see here the flow of energy in the building, where it flows to. So, taking the example, distribution of hot water for heating. So this hot water is used in the room for a static heating or thermal activated building system as a taps, or the heat is also used for fan coil units, for example, in rooms, or even for an air heater in an air handling unit, what we show here. So with such kind of chart, we can visualize the energy flow, and that's the basis for a successful audit. The standard 15232 defines defines four classes of energy efficiency for a building, A, B, C, and D. Where we say C, the C level, that's actually the reference, that's the average of today's building. And A is a high performance building, D would be a very old building without building automation and control systems installed usually. The standard defines functionalities that tell you which functionality has to be implemented to achieve a certain level of energy efficiency. In other words, to achieve the level A, you have to have a room control installed with presence detector. This information has to be collected by an individual room controller the room controller has to be communicative and he has to send this information to the energy generation part. And now in the eu.bac we defined a checklist. That's what you can see here, very small actually on screen. That's a checklist with all these functionalities. So what we do in a building, we go through the rooms and we just mark whether a certain functionality has been implemented in the room. Then of course we also have to set how big this room is, and well, like this we are weighting the different rooms to each other. It doesn't make sense that a 10-meter square room is highly efficient and next door the 100-meter room is not efficient. Then of course the 100-meter square room is of higher importance. And now all this information is collected, and at the end with this tool we are calculating the energy level of the building. So if you want to do such an audit in a building, we actually go through these 4 steps. First, in the preparation, you have to get the overview about the floor. Also, you need the floor plans of the building. You have to understand the energy flow in the building, and then we set up this checklist. Then we have to go on an on-site inspection. There we are recording this building data, put it in this tool, and like this, the energy efficiency level is calculated by the tool. And then this information has to go through the registration process. We have to go through a quality control. There are a set of experts are available that make the check of the tool set up, assure the quality, also ask the necessary questions, what can be done, and at the end you get the declaration, actually the certificate about the energy efficiency of the building. All this is supported by the KPI values. I also already mentioned in the beginning of this speech, KPI values defined by the European Building Controls Association that have to be implemented on the control system, and that's actually help you to supervise the performance of your system and also create warnings or even alarms if the values are starting to deviate or out of the defined normal bandwidth. So the benefit for you, for a holder, owner of such a building, is that with this methodology and with a regular audit, you secure that the building automation control system is working correctly, and it saves energy and life cycle costs while maintaining the desired comfort level. Because it's based on the standard, we also it's scientifically proven by the German university. The auditors have to be accredited by the eu.bac, etc. Here, the result, the points, yes, we are collecting points of 0 to 100, and you see here a sea-level building. A sea-level building, that's today's average of the buildings based on this 15 to 32. A sea-level building would be in the range of about 55 to 64 points. And for a AA building with all these functionalities, demand control functionalities implemented, you'll get a range, you're in the range of about 85 to 100 points. So also the value for the different stakeholders involved in a building or in a construction process, we have listed here also the benefits for consultants and planners. For them it's a help, it's a good guideline to specify a building automation and control system, and also to specify the technical infrastructure for such a building. Then the system integrator, those who are implementing this system and also make the commissioning afterward. It gives you the opportunity to provide the products and services based on this independent assessment. Yeah? It's not just selling products, no, it's selling products in the right content of the functionalities. And then for the building owner, of course, I think it's the most important benefit, because about 90% of the energy is consumed during operation and not during construction. The building owner gets optimal operation, continuous monitoring with the help of these KPIs, and based on that he can make his decisions. It reflects the environmental responsibility also of the building manager, and it's helpful to advise, helpful advice by accredited building automation expert. That's a graphic that helps you, that visualizes also a little bit the impact. I mean, you can install in a building a very efficient system and then you let it run. And exactly what happens then is actually the blue curve. The blue curve means you install it, you let it run and forget about it. So it deviates. It becomes more and more inefficient. But with such a methodology of auditing on a regular basis a building and also taking the necessary measures to maintain or even improve the energy efficiency, you get to the green curve. That means that the decrease of energy efficiently is always reset again. Always when you take measures, these measures sometimes are just readjustments. A very, very logical example is you're configuring your building that's to be used from Monday to Friday from 6 in the morning to 6 in the evening. And one Saturday there is a special event in the building. And what happens? The facility manager goes there and changes a scheduler. That the building is also in comfort condition for this Saturday. And then this setting is lost. It's forgotten. It's never reset. And what's happened? If you don't monitor that, from this time on, the building will be heated or cooled even on Saturdays when it's not used. So, saving energy, reducing or optimizing our resources, reducing our carbon footprint is actually quite easy. We have to save energy. That's what's actually what we want. We want to save energy without loss of comfort. And if we want that, we just have to increase efficiency. Increase of efficiency means avoid waste. Avoid waste, that's always the first step if you have to improve anything. Because waste is a human activity that consumes resources but does not generate any value. And that leads to operation excellence. In other words, and that's Paul Klee, the famous artist, he said, nature can afford the waste in everything. The artist must be thrifty to the last. And we are the experts, we are the artists in our business with an increasing energy efficiency of buildings. And with these words, I'd like to thank you for your attention. And I'm open for questions.